So when you've read your last symbol or your last substring, if the state that you're in, if the state that your GNFA is in, if that is in the accept state, then that GNFA accepts the string. Okay, so it's pretty similar in concept that way. Accept and reject as with the finite automata that we've done before. All right. Okay, so here's your input string W. Okay, now look on it as a concatenation, if you like, of k. I'll probably say a little k here, of k substrings. Okay, and you'll read the first one, and you're in your start state, right? And if there is a transition arrow from your start state to some other state, and on that transition arrow is a regular expression that this substring W1 matches, agrees with, like, I'll put it this way. Easier, on to the next square. This WI here, it's a substring of your W, right? So think of your input string W as concatenated substrings, and you've got k of them. Okay. Well, let's talk in general. Let's say we're talking about the ith substring, WI. It'll just be a sequence of symbols, and you're looking at it as a substring, and you're calling it WI. Now, that substring will be a member, well, if it's a member of the language of this regular expression. So remember the L of R, so R is a regular expression, and L is the language. The L of R means the language that this regular expression R here describes. Okay? So if this W is a member of this language, and in a sense you could say this substring matches that regular expression. In other words, it's a member of this language. Okay? If that's the case, then what happens? Well, you will move from this state to, so say you're in this state, that's your current state, okay? And in comes this substring. It could be, it'll be a sequence typically of input symbols, a string, well, a substring, okay, WI. And you're in this state, let's say, that's your current state. And let's say Ri is the label on the transition arrow from this state to that state. Okay? So this substring then matches the regular expression here, or equivalently, it's saying the same thing in different words. This substring is a member of this language. Right? The substring describes a language, but like the set of all strings. That you can generate with this regular expression. Okay? Alright, so I'll say it again, because this is your current state. You read in this substring WI. This substring here is a member of this language. Or in a sense it matches this regular expression, in which case you make a transition from this state to that state, right? using the transition function, right? That's how it functions, and you just keep doing that until hopefully once you've run out of substrings, once you've made a transition after reading substring WK, you will be hopefully in the accept state, and then you've run out of string, and you're in the accept state, and therefore the GNFA accepts the whole string W, where W is like a concatenation of these substrings. That's how it works. All right. Okay, so that's the walkthrough of how GNFA works. Now we can use the GNFA. Let's go back now to the second part of the if and only if proof. So now we're doing Lemma 1.60. That's the only if part, right? So we'll do it the usual two steps. We start with the DFA, right? So you start with your DFA, and let's call the machine that recognizes it N, and the language that it recognizes, this DFA recognizes, is language A. Okay. Now that's how we start. Then we have to convert the DFA into an NGFA, right? And you do that. That's fairly easy. That's not difficult. You add your extra start state, you add your extra accept state, you make those connections with null set labels, blah blah blah. All the nitty-gritty details that we described last time. So you generate your NDFA. Sorry, GNFA. Right. Okay. So you now have your GNFA. Call that machine, that automaton, call it big G, like this. And what you do next, so you've now got your GNFA, and so you now move it to the second step, and you want from that GNFA, you want the corresponding regular expression that corresponds to that GNFA. Okay, that's step 2. So how do you go about finding that corresponding regular expression that corresponds to that GNFA, which in turn you built from the DFA? So from DFA to GNFA to the corresponding regular expression. So the question now is, how do you get from the GNFA to the final regular expression that corresponds to that GNFA? Well, from the talking before, we're going to need to. Now, the earlier talk, that was the theorem idea, the proof idea. Okay, and the idea was to rip out one by one, rip out a state and repair the damage. Modify the labels on the transition arrows between any pair of states, Qi to Qj. You modify the labels on them in the way we described earlier session. Okay. Now, to do that, there's a routine. Now this. How to put this? Some of you have a computer science background, and you're just studying this course out of interest, maybe, like my son-in-law. Perhaps because it's a gap in your knowledge. Perhaps you did not take a theory of computation class. Perhaps you're just curious anyway. Perhaps you're interested in computation, and theory of computation might be a little ahead of the level that you're studying at the moment. Maybe you are more math and or physics types, and you're not quite so interested in theory of computation, but you're doing it anyway because maybe out of mild interest. And some of you may share my vision that the future of computation is math physics, as Moore's law takes computation down to ever smaller scales, and hence quantum mechanics becomes appropriate, and therefore the future of computer science will be decided increasingly by math physics type people. And so if you're a math physics type and fairly young and you see your future in computation,